2 weeks ago, meteorologists first found an anomaly of an upcoming system coming out of Alaska. The big dip in the jet stream would allow extremely warm temperatures that would break many records across the nation. As the low pressure system made its way into the U.S., many started predicting the heavy snow amounts to come. But there was one problem: tropical moisture combined with a cold front. The cold front was acting as a sort of dry line that would not only produce prolific amounts of snow on the backside of it, but in front would contain a tornado outbreak. Today, we are looking at Winter Storm Isaiah, its effects, and why this system was so powerful. Stay tuned to the end of the episode because we are going to look at some of the unseasonably warm temperatures that are going to be sticking around to the end of the month and answering the question, are we going to get some snow? And in some places, how much rain is still coming because, there's so much flooding right now that, people can't recover from it. So many big, extreme questions that need to be answered. And that's all upcoming here on the EF Show. Okay, welcome to the first official episode of Season 2. Last week I was going to post an episode on Friday to initialize the new schedule, but obviously a huge low-pressure system containing a tornado outbreak occurred, so I didn't get much done. I had been looking the weekend before at many models, and this is not a sponsor, but I love using pivotalweather.com, and I think you should go check it out. This is where I use all my models to predict the weather with. They have everything from NAM to HRR. You can even look up GFS, Euro, all the other ones that are in there. And it has everything. It has NWS Outlook, Storm Prediction Center stuff. So really, it's a good resource that you can use. And the best part about it is it's free. So once again, they are not a sponsor, but I just wanted to say where I got this stuff from because I just love using it so much. And there was something off about Friday the 10th, and I was looking the week before and just after New Year, and there was really a warm temperature variation. So very warm temperatures in the eastern U.S., but colder temperatures in the upper plains and western U.S. Thinking it was winter, I looked up some other weather models to confirm the fact that there were going to be very spring-like conditions. And the bad thing about spring-like conditions is if you combine that in the south, especially at this time of year, where the only tornadoes, if they're going to happen, are going to be in the south generally. Now, of course, those two tornadoes in Ohio changed how that system normally works, but looking at the general consensus of everything, most storms at this time of year that are going to happen occur in the south due to their season being later in the year with the warmer temperatures. But this very spring-like temperatures system was very weird in my opinion. And how the backside of it, temperatures dropped 20, 30, 40 degrees in a matter of 5 miles. So I thought that was incredible. So you could tell ahead of time this would be a very strong system. So later that day, I was flipping through some models, and I saw the unstable CAPE, which stands for Convective Available Potential Energy. That's CAPE. And so simply, it's what makes storms severe. You can get a severe storm, and once it hits an area of this most unstable CAPE, it will actually produce and get develop a bit more, and it'll actually get worse. So you really, with this unstable CAPE, if you see a lot of it in a collected area, that is generally where the worst storms are going to be. So this unstable CAPE was all collected in northeast Texas, southeast Oklahoma, and parts of Missouri and Arkansas. So I was looking at all this, and I was like, it's probably going to be a big snowstorm because that area was projected to have, temperatures in the 30s. So I was like, okay, that'll be fine. We'll look at some snow, maybe forecast some ahead. And with the new year and everything, and us starting to do some forecasts, I decided, I should practice forecasting a little bit and looking at like what common things, some correlations, and a few other things involved into making a few predictions and forecasts. So I went in looking at it as a winter storm, and it snows in the U.S. Across the whole winter season. So, I mean, that's just a normal thought process, really, is to think, okay, big storm, snow. And so I checked out the NAM model, and this is a model that I had never used before this time. And I was like, you know what? I should check out the snow, just see, what type of models that this thing produces and everything. And so I decided to click on it, and I accidentally clicked on the severe mode because it's right above the winter weather mode. And what I saw was a potential severe threat, but it was as far out as the model went. And what amazed me about it is, you don't see this type of system produced at this time of year. Now, I mean, it's crazy to think of tornadoes in January, but something that I didn't know before, but the Weather Channel actually talked about, is there have been many outbreaks in the past decade that were in late January. Generally, they're in the 20 date wise, so we're a little bit earlier than normal, but still, there is at least one major outbreak containing 20 or something tornadoes or more. So I think it's quite interesting that, that something that people don't realize, and, me, I actually study the weather and everything, and I never knew that. I mean, I've done episodes on this EF show about, what seasons are when and stuff, and I never knew about those outbreaks, so I thought that was quite interesting. So that model I looked at was for Friday at 12Z, 7 a.m. Eastern Time, and at 6 a.m. CST. And to give you an idea of what that Z time is, that's kind of the universal agreed time. So if you look at the time zones, let's just say it's noon, so 12Z. You subtract 5 if you're in the Eastern time zone. If you're in the Central time zone, you subtract 6. If you're in the Mountain time zone, you subtract 7. And the Pacific Standard Time is -8. So, I mean, looking at that, you go down 12 minus 5, 12 minus 6, and basically it's subtracting. It's not that hard. And that's how you decide on what your local time is of that. So I thought, you know what? How about we make a forecast and a prediction on what's going to happen and see if the basic data can get us as close to accurate as possible? Because I'm doing some studies right now on forecasting and stuff, but with the basic knowledge I have of it as of this storm, how about I look into, forecasting with little data and not a ton of it? So, all models had the early afternoon on Friday, likely for severe weather on Monday. So, looking at all this, that Monday I was looking the week of, and Friday looked super severe. And I was looking at it, I was like, okay, maybe Saturday. I saw that Saturday had a chance, but it was like only in Louisiana. So I was like, okay, you know what? Let's go ahead and focus on Friday right now, since that is sooner in the week, and we'll focus on the other stuff later. So I made my prediction that late Friday afternoon, that convective available potential energy, CAPE, would allow supercell thunderstorms to develop. So just to give you a quick fact, I believe the statistic is 1 in 10,000 storms are supercells. So the fact that there are many of these is quite incredible in my opinion. So these, the CAPE would allow supercells to develop. Those supercells will go on to produce tornadoes right where Oklahoma, Texas, Louisiana, and Arkansas touch. The result is a model that the NOAA, the Storm Prediction Center, had posted, and it was issued on the 7th. I was looking at this, and they did it earlier, and then they changed the forecast region and stuff. But the day 4 severe weather outlook had a 30% chance right where I called it, and a 15% chance just outside of that. So I was super excited because, I mean, looking at the I cannot speak. The basic preliminary data allowed me to be able to see, okay, this is the general area, so let me make my prediction. And it just happened to be that's pretty much in the bullseye of where all that is at. So, I mean, I guess I'm just kind of lucky that I was able to look at that. Maybe it was just some, hints ahead of time. But, I mean, once this was posted, people all over the nation and storm chasers across the world turned to the south part of America. And East Texas little did they know it was about to get a battering. So all of that was, pretty accurate for how the storms turned out. But it's amazing, in my opinion, that, you look at the severe weather outlook and they only gave it a 30% chance. But even that same day, they changed it over to a significant threat. So while we're still giving it that 30% chance of a tornado, you know, you're looking at it and you're saying that there's a significant chance too. Maybe it's just that, variation in models, it's different people who do it and everything. But it's amazing to see, how many times that there's a significant in that region, how many tornadoes are condensed. So if you do the density of tornadoes, they're all pretty much within that one region. So, the area predicted on Wednesday supports my prediction. As we got closer to the day of, East Texas and West Louisiana development was predicted later and later. Instead, a new threat arose in Oklahoma. So this storm went from being a Friday afternoon, early afternoon storm, or even at night storm, to a situation that was going to be pushed back into Saturday. And here's an example of the supercell composition, and it's interesting to see, on Wednesday, it had most of it kind of on the same longitude of Oklahoma City and parts of, Dallas and Austin and all the way down. It's right along there is where that big, thick area where most supercells are going to be. And there is a dot of yellow there in that middle section of Texas, of the eastern Texas portion, and that's going to signify, where the highest chance of the most supercells are going to be. But you also look and see, okay, you have stuff in Arkansas, Louisiana is covered in some of that stuff, but there was a small chance in Oklahoma of having it, but Texas is really what we're looking at. So the actual scan in real time shows a massive amount of development over central Oklahoma, and that is going to prove later. You look at some of the tornado warnings that were over Tulsa, and many of those I was actually live looking at the radar when that warning was out, and I actually had a few minutes before posted on Twitter saying, hey, these storms are rotating, let's look at them. And then a tornado warning was posted about 5 to 8 minutes later. So who knows, maybe that could have been correlated. The National Weather Service might have seen it, or not. Maybe it just was a happy coincidence. But really looking at where that threat's at, the northern part of Oklahoma is really where that's pounding down. Looking at the colors and managing them with the numbers, central Oklahoma had a 2 to 3, I guess it was 2 to 5 on the composite scale, and then you look at the actual real-time data, and they're at 10 to 12. So it's amazing to see that. Also, another thing I found interesting, that eastern Texas portion was moved a bit, kind of Dallas area was moved west. It was pushed a little bit north, so it's like west northwest. And then there was kind of like a hook that kind of dipped down in the very northeastern part of Texas. So I thought that all that was interesting to see how accurate that was, but that little change and how much that change actually affected how people prepared and stuff. And looking at the SIGTOR, the significant tornado parameter, which is, what's the worst tornado going to be? Where's it going to be at? We're looking at it for Oklahoma, and it's, doing it on Thursday. It's not East Texas and Louisiana. It's in Oklahoma, smack dab in the middle of Oklahoma City. You're looking at a 3. And, people were like going crazy on this because, it's so condensed in that one spot. And that was unexpected even 24 hours before. So, that rapid development due to that system is changing. It's throwing people off. It's hard to predict systems like this. It's hard to even guess that these are going to happen, let alone be able to say, okay, we can guess based on this knowledge that we can say that A, B, and C is going to happen. So on that Thursday at 00Z, I did the scan, and we got that, core right in the middle of Oklahoma, but that is the only yellow to red part that is going to give us that 2 to 4. And, the real time isn't as far south. There that blue sector that's in the middle of the Oklahoma East Texas part, it's a little bit wider. It's not as tall though. So I mean, the day of, we're looking at Friday, and there is a massive thing right up. It splits Oklahoma right up the middle, and it is just blowing up oranges, yellows, and reds. And so that is not what you want for this. You want stuff that's in the like light gray, because that's no tornadoes, or no to little tornadoes. But I mean, that red and that vibrant fire color is where all the development's going to be happening. And there's parts of northeast Texas that had little speckles of this too, but it's really presentable in the middle of Oklahoma. And I mean, it's crazy to look at that because, you see these systems that are planned ahead of time. This one just completely changed. It took like just one step and it went up. I mean, in a matter of an hour, the predictions went up a level. It was crazy. So, right after this break, let's look at a more detailed before, during, and after examples of how accurate predictions were and what the actual outcome was. Okay, so let's look at the unstable cape at 21Z, and I mean, you really have two separate portions of this. There is the entire southeastern Texas that is just covered in that unstable cape, and then you have that central part of Oklahoma that is really kind of a separate cell, what it looks like, and that's still kind of based around Oklahoma City, and that's really what kind of happened in a way. But it happened in a very unexpected way that the cape couldn't show ahead of time, but it accidentally kind of did. But in my opinion, it's amazing to see, how you go from, I mean, 3 hours before is such a big system to just, it kind of gasses itself out. It uses a whole ton of those resources in that, and it needs to recuperate and come back. And this being a rotating system, it's pulling energy from everywhere. 360 degrees is where it's pulling this cape from. So, I mean, really anything around it is going to allow it to strengthen. So, the real-time data shows that the thunderstorms out in front of the main line would be severe too. The previous had shown some potential for some development of storms across Missouri and parts of Illinois, Indiana, into Ohio. But, I mean, really looking at it afterwards, you cover all of Arkansas, basically this south two-thirds of Missouri, parts of Kansas, you look into southern Illinois, and even into parts, Memphis and those places in Tennessee, is where that action is really getting in. But the rest of it is about the same. That system, though, the real time, looking at it, that kind of split off that we saw originally isn't there anymore. It's just kind of a weaker spot, so it's still there, so there's not a complete disconnection, so you're not looking at two different kind of storm energy positions. You're still looking at one, but you can really see where the wind's pushing, because I mean, looking at if you can see this in the video right now, but looking at Louisiana, you see that kind of going north, straight north, and you look at Texas, and you see that very left portion of blue going up into the middle of Oklahoma and kind of pushing up into the very southern tip of Kansas. So, I mean, looking at that just shows you how powerful the winds are. And now let's look at the next day. So this is the 11th, which is Saturday. And this storm was so powerful that the early helicity models showed what storm structure was going to look like. And, I mean, if you can see this photo right now, you should look at it. It's amazing. Looking at it, a few notable things about it. There was a squall line going through Mississippi. And looking at this, I mean, the colors just contrast and condense there at the last second. So when the storm goes through, it's going to be powerful and everything all at once. And, I mean, another notable thing is the calm spot after the storm passes in Arkansas. There is a period on here at this was initialized on Wednesday at 00Zs, and then this is for Saturday at 12Zs, so we're looking at 6 a.m. Eastern Standard Time, and then we're looking at 5 a.m. on the CST, but it's just crazy looking at this. I mean, it's fascinating to me. I can't even begin to describe it. You could really see that ridge building, and then there is a part over so that this part of the storm is where the low was over the southern parts of Illinois and Missouri, and you could see that rotating pole where the snow would be on the back side of it. And that's our other point is that there's snow on the back side. It's that dip, if you could see it in Oklahoma. There's kind of a notch in there where where that white's at, where there's nothing on the southern, southwestern, and southeastern side of it. But then south of it, there's a little bit of energy, and then north of it, you have that heavier snow. But you can really see that section where that rotation is going to be a cold front, and that's going to allow it to cool down quickly, and by the time that snow gets there and that energy, you're going to have a lot of snow. And that's something we saw afterwards, is that many people cleaning up debris were standing in like 2 or 3 inches of snow. Oklahoma got it, Amarillo, Texas got it, a lot of other places got it, but it's crazy to see the intensity behind this. You can really, just looking at this picture, feel it. You can really, if you've ever been in front of a squall line or been in one while you're outside, you could just feel the wind hitting you, pounding you, almost want to knock you over. And yeah, that's, straight line wind is just as dangerous as tornadoes themselves. I mean, you can get straight line winds of excess of 80, 90, even 100 mile per hour. And some of those are associated with microbursts, which then that adds, another 150 mile per hour onto it. And, you're looking at 190, 200, and that's enough to like knock a building down. So, I mean, that's just crazy. So, I mean, here's what the Weather Channel's radar at the time showed, and it's amazing to see. I mean, it pretty much matches it. There's 1 or 2 little kinks in the line that don't exactly match it, where like one was surging forward or something else, but I mean, a lot of this, it's amazing to see how the forecast models and radar were perfectly able to nail this. So, quick note on this, the Cape was quite interesting to look at because, it didn't suggest this development of storms and producing tornadoes in the Carolinas the next day. It showed most of it in Mississippi and western parts of Alabama. But back up to that Weather Channel model, and the radar, you can just see the front edge of it, and that line, it matches it perfectly. Goes for hundreds of miles from the very southern tip of Louisiana all the way up through the middle of Indiana. And I mean, it's just solid the whole way. I mean, there's no stopping this thing, and you can see some rain out in front of it. But something I wanted to point out that was fascinating is that part that kind of juts out over the very northern part of Mississippi. And you kind of see how that separates where the Arkansas, well, really where Memphis is at. If you look right there in the middle on that southwestern tip of Tennessee, something that is, in my opinion, one of the most interesting things that I've found out recently is that that's actually the wind pushing off ahead. It's pushing the line. And so you'll actually see precipitation be pushed out of the air and, lofted a little bit more, but really the whole wall kind of moved. And you can get that on radar scans. That's why ahead of some of these storms, you'll see like a brick-like shape, or the whole line looks like it juts out all at once through one radar scan without rotation. It's because that, squall line got pushed by some backwards directional wind, and all that comes from warm and dry air going in, and there's that moist there's that moist and then sometimes cool air, but whenever that cools down, all that air has to get cold at once, and when it does, it just drops. It is like a anvil falling out of the sky, and when it hits, it just spreads everything everywhere. So essentially, that's what a microburst is, but that same logic can be applied to squall lines, because you're pushing, you have to get all that wind from somewhere, so you're looking at downdrafts and RFD, rear flank downdrafts, and I mean, really, downdrafts and microbursts, downward moving air, is the game here on how all this works. A few other things, looking at some of the Cape and stuff, I mean, it's amazing to see, how underpredicted the Saturday event was going to be, and how, how perfect they nailed Friday. Not how perfect, but how, almost exact they nailed Friday. But, Saturday they were so far off. So a quick note on this is, a die-off in Cape was predicted just after this scan. And I took this scan on Wednesday at 00Zs. This is a NAM model. And this is for Saturday at 12Zs. So you have to look, and that was expected to die off. So, I mean, even maybe a few water spouts, but maybe southeastern Louisiana stuff and the very southern tip of Mississippi, but nothing like what it actually was. And, I mean, but late that night, what was left of Winter Storm Isaias still had enough to pump out some tornadoes across North Carolina. And I have a radar image here of a tornado warning Sunday at 2:41 a.m. It was in a severe thunderstorm warning associated with this quick system, and the tornado warning was in a. Luckily, there's only 965 people in the path of it, but I mean, looking at some of these towns, you see Hamilton, Windsor, Maryhill, Plymouth, Jamesville, Williamston, and a few other ones, and even within that, there were a few more tornadoes. Not reported, but they were suggested by radar indicated rotation that were associated with the line. And, I mean, all of that is amazing to look at. And, it's just crazy to see, how much could come out of a simple system that a week before had just been hinted at. And then the same week, at the beginning of the week, there's so much evidence behind it. It's fascinating to follow the whole thing. It's the first time I've ever followed everything from beginning to the end. And I would highly suggest it. It's amazing. It feels rewarding in a way because, you were there for the whole thing and you were able to see it all. But looking at January 13th, it was the very, very end, the tail end of whatever was left over produced a tornado. And this my first one is my first photo is a Twitter post of a structure collapse at Union Intermediate School near Clinton, North Carolina, from a possible tornado. Reports of kids injured, and these are storms that they have been looking at all afternoon. And they were saying that the Sampson County Weekly was quoting that you should take warnings seriously when they are posted. So a radar scan of that time, this is a radar scope scan, shows that there is some tight couplet rotation west of Keener, northeast of Salemburg, and then kind of that northwest of Clinton. So really closer to Keener and Salemburg. But looking at it, it's where those red and those greens combine right there. That's where you have rotation. And those little pixels, when they're up close and you have that kind of reddish maroon black color, that's really what you don't want. And then you'll see some yellow, and that's where it's bad. That's where debris is getting lofted and stuff. So, I mean, looking at this, it's obvious there that there is that rotation, and it's just, it's obvious that while that is a bad storm, it's not a very strong one, luckily. So that tornado, if one were to touch down, would not be too bad. So the National Weather Service in Columbia posted that, one second here, my thing is going crazy. So the National Weather Service survey team has confirmed a high-end EF2 tornado, so almost an EF3, at North Central High School in Kershaw County, South Carolina. The estimated winds are around 130 miles per hour. The data is still preliminary, as the team will need to evaluate the path, width, length, and height of the tornado. So looking at all that, you have to be able to look at everything and see it. There's a photo here of the school roof that had collapsed, and then the National Weather Service posted about some of their other findings, and something that's kind of crazy about it. They found, the gymnasium had collapsed inwards, the stands and bleachers were ripped apart, and there's a path leading from and to the school of debris. It's a thin debris path that you can really see where that tornado went. And it's just kind of crazy overall to see, how small some of these tornadoes are. But, they're within those vortices going around, it could be the size of a table. Those vortices are so powerful. And that's what made examples of, like, El Reno and some other tornadoes, more Oklahoma, some of those ones so bad is that you had those outer vortices of winds, those tornadoes moving at 200 miles per hour, spinning at that speed. Well, you have those outer vortices that are moving that plus 100 and some, you have 300-mile-per-hour vortices that are just whipping out and hitting things. And that's the same thing essentially on smaller tornadoes, just less, it's on a lesser scale. So looking at overall storm reports, I mean, it's just, this map is just scattered in them. Most of them are wind damage. There are many wind ones, but I mean, looking at them overall, there were, I believe, currently the confirmed count is 34 tornadoes. Now, if I don't have that right, that's because since the time of us getting this, they have updated a few more. But, I mean, all across the nation, you're looking at everything, from the western parts of Oklahoma and central parts of Texas, all the way up into New Jersey, Philadelphia. There's heavy winds and stuff. And it's really interesting how this crazy system works. It all came out of Alaska. Just a little disturbance created all of this. Now, it isn't crazy that it occurred in the south, but even severe storms reach places like Ohio, where, as I said earlier, the 2 EFO tornadoes hit Champaign County, and this is all related to climate change, really. Our warm temperatures are allowing the storms to go that far north. Normally, this would have been a deep south thing, but with warmer temperatures already, it made matters worse. And when you mix, that May-like temperature and humidity with a rotating system, I mean, you're going to end up with craziness. You're going to end up with horrible, horrible things happening. And I mean, just looking at the records, everything, east of, Illinois, Mississippi, everything east of there were records just blown apart because, I mean, because their record or tied or broken, and, I mean, it's too warm. It's too warm. Whenever it's not snowing and you're not getting snow or anything, you have many places where it's just a cutoff line of a few degrees, and places south of that cutoff line haven't gotten an inch of snow yet. Places north of it have gotten like a foot already. And it's just, that's a direct consequence of climate change. You get to see all this in real time. So, I mean, climatology is such an interesting thing to look into, and meteorology and that go hand in hand. But I mean, it's always interesting to read up more and learn more about this. And I mean, something I just realized too, almost all of Florida broke records, so I thought that's actually quite interesting there, because it's always hot down there, so but they broke records down there, and that's interesting. So yeah, that's all awesome. But I mean, it's all awesome to look at the data and stuff, and this is something that people are going to be studying for, probably forever, or storm systems like these. And we're going to come back with more research and more findings, and eventually we could fix all this, and maybe this can go away, or maybe we could find out some solutions ahead of time to make life a lot easier for people. So since it is season 2, we are splitting this up into segments, so that is the end of that. And we are going to look at our new segment, which is This Week in Weather News. So essentially, we're going to have a break between each, sector and everything, and looking through each portion of our episodes. And then we're going to come back after the quick break and introduce what we're going to be talking about in the other sections. So this week in weather news, Australia is still burning as their drought continues. 2 photos here, one of a massive fire, and these are actually creating thunderstorms, which are raining ash and flames, embers, and a bunch of other things, which is horrible. The skies are red. It is just insane over there right now. Luckily, though, they are getting some rain that they need right now, and it's important that they are able to get all this, because Australia is just going to keep burning until a solution comes along. So hopefully some of this rain can help put some of it out, and it will aid those firefighters and wildlife conservation people who are trying to save the animals in the landscape. It's been Australia's hottest and driest year on record, and many Australians entered the new year under apocalyptic blood-red skies as smoke from fires choked the country's southeastern coast. Person said, "I looked up and it looked like the end of the world. Armageddon is here," said one woman in Canberra. And that is from NewYorkTimes.com/The Daily. And the fires have burned through dozens of towns, destroying at least 3,000 homes, unbridled by continuous firefighting. The blazes have returned to some scorched areas to level what is left. And that's sad, honestly, reading through that, thinking about that. People, they went back after everything had been burned down to look, and maybe sometimes they built up like little villages, and I mean, there's plenty of places they have tents going. Then the fires came back with this such dry heat, and then it's all on fire again. Okay, so 15.6 million acres of Australia have burned. U.S. firefighters have actually been traveling over there to help those down under. Many rely on those helicopters to get water to put fires out through thousands of gallons falling from the sky. As of right now, 24 people have died in New South Wales. That's all very sad. In other news, thanks to the snowy side of Winter Storm Isaiah, more than 1,000 flights were canceled, most of them at O'Hare's International Airport. At least 3 deaths have been blamed on a severe winter storm that moved across the Plains and Great Lakes region on Saturday. That's from weather.com. And many big waves were reported in the Great Lakes. Snow totals have been crazy. Everywhere in the northern latitude of Chicago is getting snow, and a lot of it. But everything south is getting rain, so occasionally it's freezing over, and that's creating all these, safety hazards that can be a very big problem. So, looking at all this, this is our last segment here, but it's going to be really interesting to see how much rain everyone's going to get, and those who get snow, how much stacks up, oh my gosh, how much stacks up by the end of the winter. Will we see more thunderstorms, or will we wait till the severe threat in the spring happens for those severe storms to return? Can we expect to see any rainfall in the coming days? So let's go ahead and look at your forecast for the next week and get you prepared for some things that might be happening. Monday, we're looking at some snow in the Great Plains, some lake effect in the northeast due to a dip in the jet stream pulling cold winter air out of Canada. We will see much normal January temperatures, teens across the Midwest, Northeast, and 40s in the South. Tuesday, we're looking at lake effect snow and snow showers in West Texas, temperatures in the mid-20s, and in the Midwest and Northeast, in the 40s in the South. Wednesday, we have a high-pressure system over Ohio and Kentucky that will allow snow in northeastern Oklahoma on the Oklahoma, Missouri, and Arkansas border to produce. Temperatures in the mid-30s and 40s will occur across the nation, except in the northeast where the teens are expected. Thursday, with temperatures in the 40s across the nation, Louisiana will see some rain, and so will the state of Washington. On Friday, with the majority of the country in the 30s and 40s, parts of the South are looking at 2 inches of rain to come, and maybe even a weak thunderstorm. So that is your week ahead, looking at that. Obviously some new sections that we're trying out and looking at how we want to do them, so that's why those were quick. And check us out on Twitter at EF Meteorology, link in the description. And it's amazing to see, how many people came together to support and work together on all that. Communication was perfect, and this all happened to be happening at the beginning of the American Meteorological Society 100 meeting, and so you had everyone with the biggest minds on this subject in the same place at once. So it was really good to see all that, and support could be given to people that aren't even in the same part of the country. Check out our photography Instagram at EF Network Photography. And if you haven't seen our season trailer, go check it out for important upcoming events that will be changing how our show works and what the format of it is. If you're watching this on YouTube, subscribe, and thank you for watching. Make sure you stay tuned for more information, and I will see you back here next week for another episode of The EF Show.